So here is another question on electric potential. It is given that 2-point charges plus q1 and minus q2 are placed at a distance of r meters apart. Obtain the expression for the amount of work done to place a third charge q3 at the midpoint, that is the midpoint P, of the line joining the two charges. And then it is asked at what distance from charge plus q1 on the line joining the two charges in terms of q1, q2 and r will this work done be 0. Okay, so first we have to find the work done to place a third charge q3, which is basically from infinity to this point P. So we know that work done to bring a charge from any initial point I, let's say, to final point F, okay, that is equal to Q into potential of final point minus potential of initial point. So here the initial point is infinity, okay, this at infinity, and we know potential of infinity, that is equal to 0 volt, and the final point is P here. So we have to find the electric potential at point P. So for that, the electric potential at point P, because of the two charges plus q1 and minus q2, that is equal to potential due to plus q1 plus potential due to minus q2. So that is equal to 1 by 4 pi epsilon 0 q1 by r by 2, because P is at the midpoint, this is midpoint, the total separation distance is r, so as it is at the midpoint, so this will be r by 2 and this will also be r by 2. Okay, 1 by 4 pi epsilon 0 q1 by r by 2 minus 1 by 4 pi epsilon 0 q2 by r by 2. So that is equal to, if we take 1 by 4 pi epsilon 0 as k, this becomes 2k by r q1 minus q2, okay, taking k as 1 by 4 pi epsilon 0, the constant, 9 into 10 power 9, that. So this is the electric potential at point P. Now we know work done in bringing the charge q3 from infinity to point P, that is equal to q3 into final point minus initial point. V phi is 0 volt, we know, so this is only q3 Vp, which is equal to 2k by r q1 minus q2 into q3. This is the work done in bringing the charge q3 from infinity to point P. Okay, 2k by r into q1 minus q2 into q3, this. Then it has been asked at what distance from charge plus q1 on the same line joining the two charges in terms of q1, q2 and r, this work done will be 0. Okay, so let us bring this thing. just here. Okay, let's bring it here. Okay, so now let us say we have charge plus q1 here and charge minus q2 here, and let's say we pick any other point p dash here which is at a distance of x from q. Okay, and here the work done is equal to 0 joules. Okay, at this point to bring the charge from q infinity q3 to this point, that is 0 joules. So we know again by definition, to bring a charge, any other charge q3 located at infinity to point p dash here, that is equal to work done charge infinity to p dash, that is equal to q3 into vp dash minus v phi. V phi, electric potential at infinite distance, that is equal to 0 volt, we know. So that is equal to q3 vp dash. Now the only way this work will be equal to 0 joule is when vp dash, that is equal to 0 volt, because q3 will have some finite value. So the only way the work done will be equal to 0 joule is when vp dash is equal to 0 volt. Now we know here this is x and this remaining gap, that is equal to r minus x. So we have to find the expression of electric potential at point p dash. So the electric potential at point p dash will be vp dash is equal to vq dash plus v minus q dash. So that will be equal to, taking 1 by 4 pi epsilon 0 as k, that will be equal to k q1 by x, because q1 is located at a distance of x from p dash, and k minus k q2 by r minus x. This r minus x, this is vp dash, but for work done to be 0 joule, vp dash is equal to 0. So this will be equal to 0. That implies k q1 by x is equal to k q2 by r minus x. K gets cancelled, so we have q1 by x is equal to q2 by r minus x. That implies q2 by q1 r minus x by x, which is equal to r by x minus 1. Okay, that implies q2 by q1 plus 1 is equal to r by x. Okay, that which is equal to how much? q2 plus q1 by q1 is equal to r by x. We have to find out the value of x. It implies x is equal to q1r by q1 plus q2. This was asked in the question, to find out x in terms of q1, q2 and r. This here. This was asked. So this x is equal to how much? That x is distance of the point from q1, that is equal to q1r by q1 plus q2. This we calculate. Okay, this here we calculated. Okay. Hello friends, so here is another question on electric potential. It is given that two positive point charges of 16 into 10 to the power minus 10 coulomb and 12 into 10 to the power minus 10 coulomb are placed 10 centimeter apart. Find the work done in bringing these two charges 4 centimeter closer. Okay, so here let's say there are two charges. Let's call this point 1 and this charge is 16 into 10 to the power minus 10 coulomb. Okay, and this is point 1, and here we have point 2 where the charge 12 into 10 to the power minus 10 coulomb is situated, and both of these charges are 10 centimeter apart from each other. Okay, it is said to bring these two charges 4 centimeter closer. So here let's say we consider this charge as stationary, okay, and we move this charge which is situated at 2 to point 3, okay, 4 centimeter in this direction, okay, point 3. We move it in this direction, 2 to 3. This is 4 centimeters closer to charge 1. So now this gap is 10 minus 4, which is 6 centimeter. Okay, from here to here, it is 6 centimeter. Now, if you remember, we have discussed work done in bringing a charge from an initial point to any final point is equal to that charge multiplied with the potential difference between the initial and final points, that is the final minus initial points, okay, Vf minus Vi. So here this charge which is Q, let's say 12 into 10 to the power minus 10 coulomb, that is moved from an initial point, that is 2, to a final point, that is 3. So here it will be the work done in bringing the charge from 2 to 3, that is equal to Q into V3 minus V2, that is potential at point 3 minus potential at point 2. So now we have to calculate V3 and V2. Okay, so potential at point 2, V2, because of this charge placed at point 1, that is equal to Q, let's say we call it this charge as Q1 by 4 pi epsilon 0, the gap 4 pi epsilon 0, that is 10 centimeter, the distance between 1 and 2, that is equal to 10 centimeter. So that is equal to 16 into 10 to the power minus 10 by R12, that is 10 centimeter to 10 to the power minus 2. 1 by 4 pi epsilon 0 is equal to 9 into 10 to the power 9. Okay, this is coming 144 volt. Okay, V2 is calculated, the potential at point 2. Then the potential at point 3, that is equal to, again due to this charge situated at 1, that is equal to again Q1 by 4 pi epsilon 0 R that is the distance between point 1 and 3, which is 6 centimeter. That is equal to again 16 into 10 to the power minus 10 by 6 into 10 to the power minus 2, 9 into 10 to the power 9. It is coming around 240 volt. Okay, 240 volt. So the work done in bringing the charge from point 2 to 3, that is this charge 12 into 10 to the power minus 10 coulomb from point 2 to 3, that is equal to that charge Q, which is equal to 12 into 10 to the power minus 10 coulomb into V3 minus V2, that is 240 minus 144, that is equal to, it is coming 12 into 10 to the power minus 10 into 96, yes, 96. So it is coming around 11.52 into 10 to the power minus 8 joule. Okay, this is the thing. Now you can do it in the opposite way also, in the other way. That is, you consider this charge 12 into 10 to the power minus 10 as stationary, and you move this charge 1 from this point to this point, that is 4 centimeter in this direction. Then you have to calculate, let's say we consider this point as 1 dash, this point as 2 dash, and this point as 3 dash. Then you have to calculate the potentials at V1 dash and V2 dash. Okay, so the work done in bringing the charge from 1 dash to 2 dash, that is equal to this charge 16 multiplied with V2 dash minus V1 dash. You will get the same result. Now it was not mentioned in the question in which direction we can move the charge, nothing was mentioned. That's why we considered the first way, that is we considered this 16 into 10 to the power minus 10 coulomb charge is the stationary at rest, and we moved this charge 4 centimeter closer to this point, 16 into 10 to the power minus 10 coulomb. You can also do the opposite thing. You can consider this as stationary and you can move this 16 into 10 to the power minus 10 coulomb charge 4 centimeter closer to this charge. Either way will get the same result. Okay, so here the answer is 11.52 to 10 to the power minus 8 joule. Okay.